Now we are at lecture 7, where we'll be talking about multivariate regressions. So, multiple regressions. Similar to bivariate regressions, right? We're going to find a number from our output, and it's going to help us make predictions about the relationship between the dependent variable and that independent variable associated with that number. Unlike a bivariate regression, however, that looks at just one relationship only, which is very similar to a correlation coefficient, in terms of just a one variable relationship to another variable relationship. Here with multiple regression, we want to look at a whole lot of different things all at one time, because in the real world, you can't necessarily isolate and only think about a relationship by itself, right? So you have a husband and wife, but you've got the in-laws, the parents, you've got the kids that play a role in that relationship. And so this is what we're doing. We're factoring in all of these other variables that play a role in making this relationship what it is. And so one of the ways in which we do this is that one of the ways in which we isolate, the effects of independent variables is by controlling for the other variables, the other factors in that relationship. So control variables, by definition, is a variable that is held constant to assess or clarify the relationship between other variables. Here's one example. So we are doing a study and we want to understand the relationship between gender, education, and salary. So specifically, we want to know whether salary differences between men and women have anything to do with education or not. We're controlling for education, and so what we're really seeing is that if men and women have the exact same level of education, will the salary differences still exist, or will we be at an even slate? So our salary differences due to gender discrimination, right? So we're controlling for education. Salary of men with a high school education versus salary of women with a high school education. If they are the same as we control for education, then that means that there are no gender differences. If they aren't the same, then we can see what that difference is. Maybe men make more than women, or women make more than men, which we know what the actual. So another example here. Again, we're looking at the three variables: gender, education, and salary. But now we're controlling for gender. So we're seeking to understand salary differences of just one gender. In this case, we're saying women. With different levels of education. So now we're not wanting to know what the gender differences are. We're wanting to know what the difference would be based on education, right? So our salary differences due to educational attainment. So we look at the salary of women with a college degree, and we look at salary of women with a high school diploma. We may decide, you know what, we want to look at men. So we look at the salary differences of men with a college degree, the salary of men with a PhD, right? So hopefully this is allowing you to see kind of the different ways of controlling variables. There's our multiple regression equation. Very similar. It looks very similar to our bivariate, but of course we've got an additional add-on at the end now, because with our bivariate we only had b naught, right, which was our y-intercept. We had our B1, which is our regression coefficient, and we had our X1, which is our independent variable. But now we have several independent variables, so we also have to have several regression coefficients. So we have B2, B3, if, however many X's we have, we also have to have for B's. Our regression coefficients. So as you see, as it popped up on your screen, all of these definitions remain the same. We know our y hat is the expected value of the dependent variable at a specific independent variable value. We know that x is still our independent variables, b naught will always be our y-intercept, and then b1 and on will always be our regression coefficient. And the difference from the bivariate regression is that now while we are interpreting the same way, what you see here bolded is what the difference is between a bivariate regression and a multivariate regression. Here we're holding all the other x's constant. So when we do our interpretation, when we say our interpretation, the only difference here is that we're saying that once we've controlled for all the other things in this model, we can say what we say with that regression coefficient. And that sounds very vague, but we will get into specific examples moving forward. All right, so there are going to be 4 types of multivariate regressions that we're going to look at. The first one is a set of dummy variables. And usually it's a set of nominal dummy variables, because with ordinal variables we don't necessarily have to do what we do here. And so our dependent variable, still salary in dollars. Our independent variable, really we just have one independent variable, right? And it's race. But we cannot have race as just one variable. We have to split it up into dummy variables, because if we have, imagine that we had the variable race listed here, right? That means that as race increases by 1, salary increases by whatever that number would be for your regression coefficient. And logically that makes no sense, right? So race cannot increase by 1. I mean, it could, but what does that ultimately mean? And so we have to break down that nominal variable into its own individual variables in order to understand what Asian means, what black means, the difference between Hispanics and Indians, and so on. But so when we look at this regression output, we can see Asian, we can see black, Hispanic, Indian, and there's a group here that's missing. If we looked at, say, our Excel spreadsheet, we would be able to see all the values listed out for this variable called race. And the one value that we don't see right now is the value white, right? And we call that the reference group. In the regression output, the reference group is the value within the set of dummy variables that does not show up in the regression output. So it's the value when all of the x's are 0. So the reference group is called the reference group because if we did put that reference group in, all it would do, the computer would simply spit it out, because it needs something to compare itself to, the rest of the outputs to, and so that's why there's a reference group. The group that is not seen here in this output is what we know the reference group is. And so the reference group for the above regression is white federal employees. The y-intercept, which we know by definition means that it's when all of our x's are 0. And here we know that our x at 0 for Asian means that person is not Asian, that person is not black, that person is not Hispanic, person is not Indian. So what is that person? Well, the person is white. That's the only other value for this race variable that hasn't been checked off. So white would be what the y-intercept is, right? When all the x's are 0. And so the y-intercept here is, again, white employees. And what is it telling us here? It should tell you that the mean salary for white employees is about $43,000. Okay? So let's continue on in this vein of type 1 set of dummy variables, multivariate output. Okay, so looking at the output again, we now know what the constant or the y-intercept means, that 43,000 that you see at the very top. So what do the other values mean, numbers mean? Well, we know from our bivariate lecture 6 that the other numbers are our regression coefficients. We now have multiple regression coefficients and not just one, right? So when all the x's are measuring a single independent variable, the regression coefficient represents the difference in mean salary between the group represented by the dummy variable and the reference group. So understand, hopefully, now that the reference group is what we are needing in order to compare, right, what the values we see here in the output. So the reference group is being compared, white is being compared to Asian, white is being compared to black, is being compared to Hispanic, is being compared to Indian, right? So all 4 of these regression coefficients are being compared to the reference group white. Okay, so the mean salary for Asian federal employees is $4,800 less than that of white employees. I'm going to let that sit a little before we move on. So you see the Asian value there, and right beside it, under standardized coefficients, we see the number -4854. And so that's telling us, as we're comparing Asian to the reference group, which we now know is white, that number is telling us that Asians make about $4,800 less than white employees. So what do you think that the black regression coefficient is telling us? That blacks made $10,000 less than white employees, and obviously we can continue on, and we know what the others mean, and they are all negative, so that should tell us that whites made the most, right, in this data set, right, and then compared to all the others, and who probably made the least? Blacks, right? So blacks made the least, followed by Indians. Asians made the second most, right under white employees. Let me give you another example, because it's this set of dummy variables can sometimes be confusing, and so I've provided another output, and this output though gives it to you with a different reference group. So let's take a look here. We've got values for black, Hispanic, Indian, white, and so the only value that we don't see here now, since we do see white now, so the reference group has to be what? Hopefully you said Asian. All right, so the mean salary of the Asian employee is $32,000, right? Because that's our y-intercept. And that's our reference group, because it's when all of the x's are 0. You're not black, you're not Hispanic, you're not Indian, you're not white. You checked off in the survey that you are Asian. Okay? And here you can just take some time to practice and understand how to interpret the rest, right? So for example, blacks made $4,500 less than Asians. This is a different year data set. This one is 1991. I believe the last one from the previous slide was 1998. But so blacks made about 4,500 less than Asians. Whites made about 3,200 more than Asians. Okay. So, we talk about mean and we talk about expected, and sometimes it can be confusing. And so I put this slide together because it's just a way to kind of sort through when to say mean and when to say expected. So how do we know when to include mean in our interpretation? Well, when the number of b values in your regression equation equals the number of expected values of the dependent variable. Okay, that was a lot of words. We're going to make sense of it now. Okay, so mean age equals b naught plus b1 times liberal plus b2 times moderates. In that equation, right, going back to that answer, right, it says when the number of b values in your regression equation, right, equals the number of expected values of your dependent variable. So here's our equation. How many b's do we see? We should see 3. B0, B1, B2. That should be 3 you should count, right? Now, let's look at how many expected values we have for our dependent variable. Our dependent variable is race, is age. And so how many ages do we expect to pull out of this, right? We expect to get a mean age for liberals, for moderates, for conservatives, which we know is our reference group, right? Because we don't see it here. It's invisible to us. So in our Excel spreadsheet, we would see all 3 of them, and the output, the Excel, what's this thing called? The Excel program, the stats program, would spit out one of the variables in order to use it as a comparison, in order to use it as your reference group. Okay, so our 3 expected values are the mean age, the age for liberals, the age for moderates, the age for conservatives. All right, now let's look at another example. In this case, we use the word expected instead of mean because our b's don't equal the expected number of values. Okay, so we have how many b's? We should count 4 because we have b naught, B1, 2, and 3. So that's 4 b values. But now we have an extra variable there that kind of throws things off a little bit, and it doesn't allow us to have the same number of b expected values as we have for b values, right? So we have, just like in the example right above it, we have age for liberals, for moderates, for conservatives, but now we have it for males and for females. Right? So we have to split it, right? So it's not just 3 anymore, it's 6. And so our b values equals 4. Our expected values, we have 6. They don't equal each other, and so therefore we say expected. Now this is not going to make or break anything, right? But it's just a matter of, this is why you say when you say mean, this is when you say expected. And a lot of times the only time you would really have to stumble on that is when you have a dummy variable or you have these categorical variables, right, that allow you to say that allow you to count. But some variables like age, you can't count how many people said they were 21 or 23 or 25 or what have you. Usually interval level variables, you just say expected. You just say expected, right? And it's for the categorical variables that when you can actually count, the number of values for them that you might, consider saying mean. All right. 2. In type 2, we have a dummy variable, just one, and we have an interval level variable, and we look at that, and in this output, our independent variables are age. What am I saying? Our independent variables are gender and years of education, your educational attainment. Gender is our dummy variable, and years of education is our interval level variable, right? Because we can have 12 years of education, we can have 20 years of education, we can have 3 years of education, and so on. So here's our equation. We've got expected salary. We can say expected, right? Because we know that there are a lot more than, there's 1, 2, 3 B values, 3 B values, right? But we have so many more expected values. We have expected values for males, for females, and then we can count years of education at 12, at 13, at 14, at 15, right? And so there's so many more expected values than the actual number of B values that we see here. Okay, so hopefully we can all agree here with the equation that I put forth. Negative 22,000 plus 7,000 times male plus 4,000 times ed years. Okay. So the y-intercept should be a no-brainer now, and you should pat yourself on the back if you said negative 22. And the y-intercept is the expected salary of a female employee with no education. Okay, let's backtrack here. Y-intercept means what again? Yes, hopefully you said it means when all of your x's are 0. So when our x for gender is 0, that would be female. When our x for our value for education is 0, right, that would mean no education. So our y-intercept is the expected salary of a female, right, employee with no education. Our regression coefficient for the gender variable, 7044, and what does that mean? So this is where it gets a little bit tricky, just a little bit, not too much, right? The expected salary of a male is 7,000 more than that of a female, right? Because we're comparing male to female. And here's the kicker. Okay, never forget this, because this is what makes it a multivariate versus a bivariate regression, right? Holding education constant, or said another way, controlling for education. So, in other words, males make $7,000 more than females with the same level of education. Either of these two sentences is just as good, as they're both correct. Okay, so let's try it for the years of education at 4148. All right, so hopefully you said that the expected salary increases by $4,148 for each additional year of education. Again, let's not forget to hold gender constant, right? Because this is multivariate, and we're talking about how all of these things play a role together. So what that really means is people of the same gender should have a 1 year for people of the same gender, so for all males or for all females, a 1 year increase in education increases their federal salary by about $4,100. Okay? Sorry about that. So the regression generates 4 values. We've got 3 B's, right? We've got the B0, B1, and B2, but we have 4 values here, so we have to say expected. We can't say mean. We have to say expected. All right, and so we can see the output here that I provide, the equation and the calculation. So the expected salary for a white female, we can see, because that was our y-intercept, is about 36,000. Okay, the expected salary for a non-white female is 29,000. And I'll let you guys take some time to do that math and to just look at the equation so that it's really making sense to you there. So feel free to pause at this point in order to just take a look at that, because I'm moving forward. The type 4 is two interval level variables. Two interval level variables representing two independent variables. Our dependent variable, still salary. Our independent variable, now we're looking at two different types of years. We're looking at years of education, and we're also looking at years of federal service, how long you've worked at the federal government. Okay, our equation is there as you see. Again, we say expected. This regression generates multiple values, multiple, because we can go on and on about how many years of education or however many years we have of federal service. Right, so the expected salary for someone with 16 years of service, right? 16 years of education, which would be what? Like a college degree. 12 plus 4, that's 16, college degree, right? And 3 years of service. So worked at the federal government for 3 years now, right after college or so. Okay? So the y-intercept should say, you should be interpreting the y-intercept as the expected salary of an employee with no years of education and also has no work experience. So years of education is 0, years of service is 0, and that's our y-intercept. You're actually not making yourself any money. In fact, based on this equation, you're giving the government $37,000. So we know that that's not a legitimate or logical number, but it's our base point. It's our baseline, right? So then we start thinking about what these coefficients mean, because that's really where the sense comes in. Our coefficient for ed years is the expected change in salary, right? $4,600 is the expected change in salary for each additional year of education that you have, holding work experience constant. So in other words, everyone with the same work experience should expect to make about $4,600 more, okay, every additional year of education they attain. And then we can say the same for years of service. The expected change in salary for an additional year of service is about $795, holding education constant. Okay? Type 5, it's when we literally just put everything together. We put type 1 together. You can see there with the set of dummy variables, Asian, Black, Hispanic, Indian. And what is our reference group there? We should say white. Yes, white employee. We put in type 2, which has one dummy variable and one interval level variable. We see interval level variables there. We put in type 3, which has dummy and interval, two dummy variables, and then type 4 that has two interval level variables. They're all in there, buddy. They're all in there, and we have this big, huge family of relationships, and we have our equation here that allows us to now be more specific about how, what we want to predict. What do we want to predict for expected salary, right? Someone with 12 years of education, let's say 12 years of education, 12 years of federal service, someone that's 45 years old, right? We can say someone that's a female and is Hispanic, right? But let's start with our y-intercept. Our y-intercept is the expected salary when all of these independent variables are 0. So literally, let's not make it hard on ourselves. Let's just go down the list and say what all of those zeros are. That is absolutely critical, especially in the early stage. You just want to go down the list and say what each and every 0 means. So the expected salary for the y-intercept is telling us the expected salary is when there is no education, someone has attained 0 years of education, has not worked a day in their lives as a federal employee, is a newborn, right? 0 years old, female, because that's also 0, and then when all these other race categories are 0, which means, right, that you are a white employee. So that's what your y-intercept is. Again, it makes very little sense here because a newborn would not be making a salary or be working in general, right? But that is what our y-intercept is. That's our baseline. And then we start other things. All right. Well, thank you so much for listening. Open up practice exercise 7 now and get going.